We've now got our final few presentations this evening, and next up is Marc Serra, who's from Presence Technology, who's going to be speaking about the customer care use case of WebRTC. Certainly in my view, you saw the slide earlier, customer care, probably catalyzed by Amazon Mayday, has been one of the most important areas for uptake of the technology over the last sort of 6 to 12 months. So I'm very interested to hear what Marc has to say.
Hello. All right. So, well, thank you, Dean. As Dean said, customer care is one of the most important use case scenarios for WebRTC, and one of the most obvious ones. So today I'm going to talk to you about our experience with WebRTC integration on the customer care on the contact center. So I'm Marc Serra, I'm infrastructure architect at the Presence Technology, and let's get started. Okay, so I don't know if all of you or some of you are aware of what a contact center is and how does it work. So I'll give you a brief explanation of the main parts of the contact center. So obviously, on a contact center, you have three big areas: customers, obviously, the infrastructure of the contact center itself, and finally the agents, the workers that work on that contact center, and are the ones that actually, at the end of the day, talk with the customer and interact with the customer. So on the contact center, you have to think of PBX. You have to think of ACD, CTI, and CRM. Now, what does it mean is that the PBX would be the very bottom of the connectivity in between the agent and the customer. It's in the interconnection in between the internal extensions of your contact center and the outer extensions of the PSTN or whatever. ACD would be the routing system of those incoming calls from the customer. Those calls may come, by the way, from SIP-link or mail or E1, T1 lines or chat or whatever, and it get routed to the agent. CTI would be probably the core system of any contact center. It refers to the ability of the contact center to interact between the PBX and the servers and the computers that actually exploit and takes care of the information of the customers and pass it over to the agents. It's really the core of any contact center. And finally, the CRM, that most of you are probably already aware of, having a database and information of the customer and exploit that. So, and finally, we have the agents. Now, it's worth mentioning that agents can be working from on premises, on the contact center itself, in the same building, so to speak. They can work remotely on remote offices. Usually nowadays, and especially without WebRTC, they are working with VPN tunnels or MPLS lines, something like that. So you have your infrastructure on your contact center itself, and then the agents work remotely using that. Or you could have a hosted environment, which is sort of a mix. So let's jump ahead into our architecture without WebRTC, and we'll see the differences when we implement WebRTC and what's really the main goals and the benefits from it. So in this scenario, I'm giving you the remote example. So you have the agent side. It's actually working from a remote office. And in this scenario, you could have like a VPN tunnel or MPLS, doesn't really matter. The point here is that the agent, it's working with a web application that goes on our web server, and the soft phone or physical phone. That is the one that's using the media for the agent, the one that the agent is using to communicate with the customer. Now, this is a really important part. This soft phone, it's the main piece that we want to remove with the WebRTC. This is our first case scenario and our first motivation to jump onto the WebRTC technology, getting rid of that part. So I'm going to show you how the media process and the login call that we call works. Now, what a login call is that in a contact center, in order to have agents waiting for a call or waiting for any information of a customer, they need to reside somewhere and be active at all times so they can receive that customer call or taking that customer call and moving out somewhere else, basically the CTI part of the contact center. Now, the way we do this is we have a virtual extension here on our PBX, and that represents the ability of our contact center to to deal with those calls, placing the calls in and outside that virtual extension. So what we have is the softphone is always locked on that virtual extension, and it's always waiting for incoming calls or outgoing calls that the whole contact center deals with. So this would be the traditional approach on a contact center. Now the softphone will be registered on the PBX. This is pretty obvious. And then you have the agent that will log in with his credentials on our IIS server, and that will be passed over to the CTI server, in this case our present server, that will retrieve the credentials and we say, yes, okay, you're a login login user that is supposed to work on this campaign or this outbound service or whatever. You belong to that group of agents. And then the present server will tell our PBX to call the softphone. Now this is really a key difference, and I will show you later on with the WebRTC. It's that the PBX is the one launching the call. Okay, it's the one launching the media traffic and initiating the call to the softphone. Okay, so at that point, the agent is already ready to receive calls and deal with the customers. Now, let's look over at our WebRTC implementation and check some differences. Now, the main difference here that you will notice is there's no phone anymore, no softphone. That it's embedded on the web application. And then there's an addition of a presence of a WebRTC gateway. Now, before that, we had some speaker talking about the peer-to-peer approach or the peer-to-server approach. Now, our approach and our first implementation is a peer-to-server. Now, this is really, really key because it simplifies things. By having the control of the server on the infrastructure end, because it's your contact center, you obviously have the control of that. You can have your firewall under control, the ports open, and you can have your turn server if you want implemented there, and on the DMZ, you have the control of everything. And this really simplifies things because it allows us, as we'll see later on the benefits, it allows us to reach pretty much any situation, except some scenarios, obviously, with just the stand server and the PBX, well, the WebRTC gateway. You don't need the turn server. So let's look at the differences in between that. Let's look over to the same login process and check the differences. So obviously, the first thing, it's the agent will contact the present server and will say, hey, hello, this is my username and password. I belong to this group. Please log me in. And then we'll have our signaling. This is one of the first differences. As you saw before, the softphone previously was already registered. Now you can have that anymore because it's embedded on the web application. So you have to wait for the user agent to log into the web application to retrieve that and start with the signaling call. So at that point, the signaling call happens. All of this is transparent, by the way, to the user. It's happening on the background with the JavaScript application. So the signaling starts, and then the WebRTC gateway will say to our backend servers that it's ready to receive the login call. So then the server, the CTI server, will say, okay, PBX number 5, please call this extension and establish the media and establish the login call. So at that point, we have the login call established on the presence WebRTC gateway that actually acts as a proxy, so to speak, and it gets delivered to the web application, to the remote agent. And then the agent is ready to start dealing with the customers. So as you can see, really the main difference is that the calls always get started on the PBX side of things, always starting here. The agent doesn't have a softphone anymore, and there's the existence of the WebRTC gateway. Now, what this all really means to us, what the benefits give to the contact centers. Now, some of these parts we already saw throughout the presentations today, but let's put them into perspective. So there's no need for SIP or physical phone anymore, neither Java nor Flash. Now, this is really a key component. Think of a contact center with having thousands of users with thousands of phones. Think of complexity of that. This is the most demanded utility of our clients in terms of WebRTC. Please implement WebRTC and get rid of those stupid phones. They're really, really annoying and bring a lot of issues and a lot of money, by the way. So that's one of the main points. Now, next one, it's multi-channel integration and reduction in agent times. What this means is that multi-channel, it's the ability of reaching out on customers throughout different channels, such as I said before, such as voice, either your PSTN line, or even chat, via web chat, or video, or whatever. everything with just one web application. So that really simplifies things. So that simplification translates into a reduction in agent training times. Think of a contact center with so many agents, with so many different softwares to deal with chat, one software for chat, one software for something else. The training times are really, really annoying. So with that, you simplify that part, less training time on agents. Reduction as well on agent position requirements. Now, this is also pretty interesting because if you have a contact center and you resell your services to other companies, those companies will usually say, hey, hello, I need 50 more positions or 100 more positions on this campaign. Please set them up as soon as possible. And that can be easily implemented with WebRTC. You don't have to think of the phones anymore, any more software, nor installation, nor anything, just URL, and you are set to go. So really quick deploys. The other good point is that the ability of highly distributed environments with agents. Now we open the possibility of agents working from their home, from a remote office without the need of a VPN nor MPLS lines, and even bring your own device approach on the agent side. It really opens up a lot of possibilities, and that's really interesting for a contact center as well. And finally, it's built to be used across the internet, the WebRTC. So that means that we have eyes and its magic, stand turn, resiliency, and Opus codec, and a lot of things that are really set to work on the internet. Okay, so what's our current status and our feedback as it stands right now on the WebRTC technology? So one website to root them all, obviously. You just have one web application, nothing else to worry about, simplification to the max. Then you have a high chance of connectivity success even without turn. Now, this was a really good point. As I said before, our approach was peer to server, and that means, or actually server to peer in this case. And this means that we have a really wide and a broad chance of reaching that agent without connectivity issues. So as our testing went on our labs, we pretty much only found that UDP limit or blocked environments were really scenarios that you actually need to use the turn server, and proxies with HTTP Connect. And that's pretty much almost the only cases that you are limited. We actually even had the possibility to work with, for testing environments in our lab, with a proxy going through Tor network and having an agent working without that. So that's pretty awesome actually. And the latency was actually pretty cool and workable. Obviously that was for lab only, but yeah, worth mentioning. And well, obviously we have encrypted traffic end-to-end. That's, everyone knows that by now. Web applications, finally, media, everything is encrypted. That's really a key component to implement WebRTC on any environment, pretty much. And the WebRTC Gateway DMZ auto-deploy, well, this is a feature that we have set, so our WebRTC is easier to deploy on the client and whatnot, and it's deployed on a DMZ. But yeah, that's not really related with WebRTC itself. So, moving on to performance numbers and codecs that we use, we currently support G711 codec and Opus on the WebRTC gateway to the agent. And that's because in a contact center, multi-channel contact center, your customers can reach you out through different kind of channels. So chances are that you are most likely be doing transcoding at one point or another. In our case, we work internally with G711, and when that reaches the WebRTC gateway, you are bound to have some transcoding. That translates into CPU hungry. I mean, Opus is pretty complex in itself, leave alone the transcoding from G711 to Opus or vice versa. That was to be expected, and it is a trade-off that we're willing to bet on, because after all, we are more concerned about bandwidth. Bandwidth is more expensive, and our clients demand that they want to reduce the bandwidth usage. And we actually did that by limiting the variable bit rate of the Opus codec. We have limited that to 25 kilobits per second, that we believe is enough to establish voice calls for the time being. As I said, this is our first approach. We will later on might move into video and other features. But as it stands right now, this is a good approach, and our clients pretty much demanded just that. So yeah, 1/3 of bandwidth usage, limited by variable bit rate settings, and it uses more CPU because of the transcoding. So yeah, that's pretty much what we have done now, and we are actually working on different other features that we think they are pretty interesting on the contact center. Now, video integration.
3-4 minutes, yeah.
That's well. That's the last one, actually. So video integration, that goes without saying. It's the next step. It's pretty challenging, to be honest with you, but we will approach it. We believe it's challenging because of hardware, really intensive performance numbers. I mean, a video is not the same as audio, as everybody knows. And we'll see how we integrate that, but that's our really next step on the developing process. Click to call. You might have seen that before, but it's the ability of the customer reaching out to you through a web browser, on, I don't know, some campaign, a web campaign or whatever. Just click there and make that call right away without the need of a phone on the customer side. Then we have the supervisor extension using WebRTC. On the contact centers, you have supervisors assigned to your agent groups that pretty much control them and take care of them. And this is a really important feature because they can make call to agents between supervisors, external calls, service observing, and so on. That's really another important implementation. And finally, further use of data channels. As we have seen through Night, I mean, the possibilities of data channels are really the deal breaker of a WebRTC technology, and we believe that there's a lot of possibilities for the contact center. Creativity and imagination being pretty much your only limitation. So that's it, and thank you very much for your time. If you have any questions.
Any questions?
Yeah, quickly, what was that?
Hang on a second, there's a microphone coming, just in case there's anyone listening on the...
I don't know the other.
Yeah, no, it's because there's a webcast, yeah.
Sorry, was that video integration about just, very quick, put down on that, please.
Sorry, the video integration?
Video integration in the last slide you presented.
Probably the first approach we'll have that will be with the web chat. Think of chatting with the customer by using video and seeing the customer, or maybe not the customer, but just the agent.
All right.
That's probably the first case will be the agent, video call with the customer. Because if the customer calls you, he obviously not going to see you through the phone. So so he might need to go with a browser with that. So that's probably a next step.
Thank you.
Okay, thank you. Any more questions?
Thank you very much indeed.